So let's look at the following problem that deals with the conservation of energy. So let's begin. A box with a mass of 100 kilograms starting from rest is pulled a distance of 20 meters along a frictionless surface and then a distance of 25 meters along a surface with friction. Now, if the pulling force throughout the entire path has a magnitude of 800 newtons and is constant, that means it has the same direction. What is the final velocity of that object if our coefficient of friction on the second half of the path is 0.25? So we basically want to find our velocity of the final system where the initial velocity is 0 because we're making the assumption that our box with 100 kilograms starts at rest with a velocity of 0. So we're basically going to break the following problem down into two steps. In the first step, we're going to find the work done on our object, the energy gained by our object on the first path, the first 20 meters. And then we're going to find how much energy was transferred or how much work was done on our object, the box, on the second path, on the 25 meters with friction. Then we're going to add those two energies up and we're going to find what the final velocity is using those two energies. So let's begin with the first part. We want to find the work done on the box by that outside force on the first 20 meters. So we basically use our formula, work equals force times distance. So our force, which was constant and had a magnitude of 800 newtons, multiplied by our displacement of 20 meters, or distance in this case. And we simply get 16,000 joules. That's how much energy was transferred by the force into our box. So let's go to step 2. Now we want to find the work done on the box on the second part of the path, 25 meters. So we basically have to take the following thing into consideration. Now our net force is 800 newtons minus the force of friction, which acts in the opposite direction. So we have to take our force and then we subtract the force of friction from our force to get my net force on the object. So force minus force of friction, multiply the whole thing by 25, our distance or displacement. So 800 newtons is our force minus, what is the formula for the force of friction? Well, it's simply the coefficient of friction multiplied by the normal force on the object. So 0.25 multiplied by 9.81 times 100 kilograms, which is my normal force on the object pointing upward. And then we subtract these guys and multiply them by the 25 by our displacement, our final displacement. And we get 6,131.25 joules of work was done on our object during the second path. So now we basically take these two energies, add them up, because that's how much energy was transferred into our object by the work done. So the total amount of work is equal to 16,000 plus 6,131.25 joules equals how much kinetic energy, because all this energy goes into the kinetic energy, into increasing its velocity, because at this point the height is 0, so there is no gravitational potential. So basically we add these two guys up, we multiply both sides by 2, divide both sides by 100 kilograms, and then take the square root of our both sides, and we take the positive velocity and we get the velocity to be 21 meters per second. That's the velocity of our object after it travels this total displacement of 45 meters.